In this demonstration, you'll learn how to use physics coupling to transfer temperature data from a fluid-solid heat transfer solution and then calculate the thermal stress in a structural simulation. To begin, I'll use this template to set up the fluid-solid heat transfer simulation. I'll allow configuration so that I can suppress the flow body in the structural simulation. Using physics coupling, I can transfer solid thermal data and fluid force data to a separate structural simulation. Let's focus on the thermal data transfer. I'll create the simulation process. Because I added a physics coupling option, two simulation processes are created, one for the fluid-solid heat transfer simulation and one for the structural simulation. I'll import the geometry. And now I'm ready to set up the simulation. I'm going to skip ahead to focus on the solid thermal to structural physics coupling. I've set up and solved the fluid flow and fluid-solid heat transfer. The setup and solution of this first simulation is shown in another video. In this physics task, the fluid flow and heat transfer are solved. In the results, I see the fluid flow, and here's the temperature of the pipe due to the heat transfer with the fluid. I'm going to transfer the temperature from this body into the structural simulation. Now, I'll set up and solve the separate structural simulation, transferring temperature data into it from the fluid-solid heat transfer simulation to calculate thermal stress in the solid. I suppressed the fluid body in the configuration task, and then I meshed the solid body. In the physics task, I need to add the body to the physics region. I've already solved the temperature field in the first simulation, so I don't need to solve it again here. Thermal stresses for the structural simulation will be based on the temperature data transferred using physics coupling. The material is structural steel, the same as the material used for this body in the first simulation. I've already added a support boundary condition to fix these surfaces. Now, I'll use the physics coupling interface to transfer temperature data into this simulation. The source physics region is from my first simulation. Because the solid thermal region is selected, its solid body is automatically selected as the location. Temperature data, which we saw in the results from that first simulation, is sent from this source location. The template I used automatically connected the physics tasks, so data from the first simulation is available to this structural simulation. This is the physics region in this structural simulation. I'm transferring temperature data into the body in this structural region. The temperature transfer is ready to go. Now I'll solve the structural simulation. During the solution, mapping occurred between the bodies selected in the physics coupling interface. In the results of the structural simulation, the stresses I see are due to the thermal expansion of the steel. The rendering of the results is exaggerated. The actual expansion is quite small. I've now finished my simulation, where I've calculated thermal stress from a fluid-solid heat transfer solution. First, I solved the fluid flow and heat transfer into the solid. Then, I solved the structural simulation, using the physics coupling interface to transfer the temperature data into the solid, and then calculate the resultant stresses. This concludes the demonstration of the calculation of thermal stress from a fluid-solid heat transfer solution.